All right, you able to hear me, right? All right.
Listening.
Yes, you are saying something.
No, I'm just saying that I'm listening.
Okay. So yeah, in terms of these, right? Like I was saying, we need to understand the relationship between distance, velocity, and acceleration. Well, distance we do know. Distance or displacement, we know that this is the path length covered, right? The path
Yeah.
length that is covered. The fact that someone can go from point A to B, right,
Mm-hmm.
covering that distance mean that that is the distance, the change in x, your change in position, right?
Yeah.
Now velocity would then be how fast are you changing that position, right? So this is the rate of change of position.
Rates of change of position.
Yes, rate of change of position, which is changing x over time. To say how fast are you covering that distance or how fast are you covering that displacement.
Okay.
So if someone covers 50 meters in 10 seconds compared to someone that covers 40 meters in 5 seconds, who's moving at a higher speed?
Person that covers 40 meters in 5 seconds.
Right, we need to calculate the speed of each, right? Okay,
Okay.
so we can say 50 divided by 10, we get that the person is covering 5 meters every second, while this one is a 40 divided by 5. You get how much is it? 8, right?
Yeah, I think so.
Yeah, so it's 8 meters per second, which means that the person is covering 8 meters each second. So this one would say the person is much faster. So
Mm-hmm.
how much you're covering, that is the velocity there. And velocity, we look at how much you are covering. Yeah. And then acceleration, that would be the rate of change of velocity.
Okay.
The moment we're saying rate, we're talking about how fast, right? So acceleration, yes, is how fast you're changing your velocity. To say, um, if you're accelerating, it means you are increasing your velocity. If you're decelerating or accelerating in the negative direction, it means you are decreasing your velocity. So
Yes.
that is what acceleration is all about, right? Now we extend the idea to what we call ticker timers, right? Um,
Mm-hmm.
Whereby this is a practical way of investigating motion, right? How do we do that? We usually set up our you can have something like a like wood, you can have some wood there whereby you can use that wood as a track, meaning where the trolley is going to move, right? So you do something like this, right? Then in that way you've set up your little slope there where your trolley would move there. So it's something like this. And then from there, right, we usually then say, okay, you can connect your trolley here. So this would be your, okay, let me try to do this. Right, so this would be your trolley here. The trolley is going to have a certain mass, okay? It's going to have a certain mass. Now that trolley is going to be connected. We connect it to a machine, right? Here's the machine there. Right, this is the machine there, but actually, to will be like this. Now in that machine, right, inside there is a needle, right?
Yeah.
A needle there. Let me try to show the needle in this way to say this is the needle there, right? That is the needle there. And then we're going to have a tape, right? That tape is going to run like this, and then it's going to be connected to the trolley there. Right, so this is what we call a ticker timer. Right, we call it a ticker timer. And then here, this would be the tape, right? The tape could be just a strip of paper, right? That is like this. Then the trolley itself is going to be connected to some mass, some two masses, right? Of some masses that will be pulling the trolley down. Okay. Yeah. So what is actually happening? Once we release the trolley, right? Usually the trolley starts around here, right?
Yeah.
It starts here. Then once we release it, right, it starts moving. The trolley starts moving along the path. It goes downwards like this. And then as it is moving, this ticker timer here on the needle, right? Remember we said that is our needle there, right? That needle is going to be moving up and down. Okay, it's going to be moving up and down. If I can zoom a bit on that to say what is happening there, your needle will be like this. You see it. So as this thing is moving, right, the needle makes a dot, and then the thing moves, right? So this will be something like this. This is moving, and as it is moving, this is making some dots like this. This is making dots like qua 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 as that thing is moving. You understand me? Yeah, so this is moving to the right, and then as it is moving to the right, this is moving up and down, making dots, making dots, making dots. Okay, so that means that you're going to have some dots made on the tape as the trolley is moving down. So this would, remember, this is our tape there. So the trolley is moving down, and then as it is moving down, the needle is going up and down, making dots on the tape. Are you able to visualize that?
Yes.
Okay. So now, since you're able to visualize that, let's then talk about how do those dots assist us, right? Those dots assist us to actually interpret the motion there, to understand the motion of the trolley, and in turn we'll be able to understand the difference between acceleration, velocity, and displacement or distance, right? So that ticker timer there is going to assist us. Now that ticker timer usually is going to have a certain frequency. They will tell you that this ticker timer has a certain frequency, and most ticker timers that we use are going to have a frequency that is equal to 50 hertz.
Okay.
Now if you can remember, since you already did waves, sound and light in term 1 or term 2, then you should understand that the 50 hertz means that you're going to make 50 dots per second, 50 vibrations per second. Okay, yeah, so it means that that ticker timer is going to be making 50 vibrations per second, meaning that as it is moving like this, the vibration will be 50 each second. It's going to make 50 vibrations like this. You understand me? So that is what is going to happen there. So now that we understand this, let's come to different cases we can have in terms of those dots. Yeah, the first one, let me just do this. Yeah, let's have some lines here. One. Oh. Okay. 2. Yeah, let's have first one here, and then this, right? Make some copies, right? Other copies, right? And then the last copy, right. So we're going to have something like this. Let's look at the dots, right? So this is case number 1, eh? Case number 2, let's see. And then case number 4. Okay, let's say it starts off with and then we'll have the following. Right, this is case 3, and then this is case 4. Right, for case number 1, right, what you must see, or rather notice there, right, is that the distance, right, the distance between those
Dots.
the dots, right, the distance between the dots, right, which we will call change in x, the distance is the same, isn't it?
Yes.
Yeah, I did try to make sure that the distance is the same. So for case number 1, we actually say that the distance is the same, the distance covered is the same, this means that the trolley was moving at a constant velocity. Okay, it was moving at a constant velocity. So because you can think of this thing here, it's moving to that direction. Or for all these cases, I want you to imagine that the motion is to the right. Okay, yeah, motion is to the right. So since motion is to the right, as this thing is moving to the right, our ticker tape, if it's making dots, you see it's making dots, so it will be in the same place, but your tape is the one moving. So if it is making dots that have equal space between them, it means that trolley there was moving at a constant velocity. Okay, it was moving at the same speed all the time. If it is 5 meters per second, it was covering 5 meters per second every time. You see? Great. And then case number 2 here, the distance covered is still the same, right? So change in x here is still the same in terms of the distance covered. So they have equal distance. In fact, let's write it this way. Instead of saying change in x, let's say equal distance between dots. Is that okay?
Yeah.
Yeah, so let's say equal distance distance between the dots is still the same, equal distance between the dots. And then here now, do you see that? But the space, the distance between the dots, right, is much larger as compared to case 1. Do you see that?
Yes, yes.
Right, but quite larger, right? So if it is larger, what does it tell us, right? Larger tells us, do you think the speed was high or low when it is larger?
Uh,
Think of the motion. Think of the motion. This thing is moving that side, and then this thing is making vibrations like this. Think of it.
it was lower.
Slower.
Because there's large spaces, man.
Oh, it's actually the velocity is constant, right? It's constant. However, it's a larger velocity. Okay. However, it's a higher velocity. Right. Sorry for that. Right. It's a much higher velocity. Why is it a much higher velocity? Well, you must understand this, right? The tape is moving that side, and as it is moving that side, this thing is sorry, it's making some vibrations like this, right? Now, if down the slope the trolley is moving very fast, it will mean that between each dot there will be a larger space, because imagine this thing lifts and then this thing is very fast to move to the right, and then it makes a dot. Very fast to the right, and then it makes a dot. You understand me? So larger spaces between the dots means a higher velocity. Okay. Is it clear though? Are you able to visualize that?
Yes. But I thought like, because case 1, right, the spaces are like most closer to each other. So the pin is moving constantly, it's making dots constantly. In case 2, then the dots, it makes dots, then the tape moves. It makes dots, it waits. That's what I thought.
It waits. No, remember, its vibrations are, remember we said it's 50 hertz. The vibrations, the time at which it makes the vibrations is constant. Like it doesn't make a vibration, stops, and then makes another one, and then, you understand me? It's very constant. However, yes, however, the tape is the one that is moving, you see? So the faster at which the tape will be moving is the one that will determine the more space there will be between the dots, you see?
Okay.
So this one we can say, compared to case 2, it was a lower velocity. Okay. Yes, it was a lower one, because now it means this thing was moving slow. That's why that's why as this thing is vibrating like this, it was able to make
dots.
Yes, you see, that have small space between them, right? Yes. Right. And then case number 3, let's look at this part here. Remember, the motion is going, the thinking is going to the right, ne? So what is happening here, and then what is happening between the space between the dots?
So it moves from a low velocity, then the distance are not equal, and it moves from low velocity to a high velocity.
From a low to a high. Yeah, it's going in this direction, right?
Yes.
So as it is going in this direction, do you see what was happening? And do you see what is happening? What is happening there? The space between the dots, is the space getting larger or smaller?
I need to be going to the right. The motion is to the right. So it's moving from small to larger. They're becoming larger.
Okay. Let me do this then. Okay. Let me try. Okay, I'm not sure if this is going to work, but let me just see if we can be able to visualize that. All right, but what is essentially happening there, if we can check, right? as this thing is moving, right? What we can actually say we're realizing, think of this whole thing here as in it's moving that side, ne?
Yes.
Do you see that as it is moving that side, actually the space between the dots was large, but as it is moving to the side, it's becoming smaller.
Becoming smaller.
Right?
Yeah.
Yes. So the distance between the dots
Becoming smaller.
is becoming smaller. So what does that tell us about velocity?
The velocity moves from high velocity to low velocity.
So it means that the velocity is decreasing, right? Velocity is decreasing. If we are decreasing velocity, what can you tell us about acceleration? Is the object accelerating or decelerating?
It's decelerating.
So the object is decelerating. Yes, perfect stuff. Now let's look at case number 4, right? Imagine this whole thing is moving to the right? As it is moving to the right, what is happening to the space between the dots?
They're becoming larger.
Right. Space between dots is becoming larger, ne? If it's becoming larger, what does that tell us about velocity?
It's moving from low velocity to high, it's increasing.
Perfect. So the velocity of that trolley is increasing, ne? And as the velocity is increasing, what can you tell us about acceleration?
It's accelerating.
So the object was accelerating. For case number 2, what can you tell us about acceleration?
For case number 2, it's constant. Or no?
Acceleration was 0.
Oh.
Because the velocity was neither increasing nor decreasing. It was constant.
Yeah.
Right. So what about case number 1? Acceleration?
It's 0.
Acceleration is also 0. Is 0. All right. So that is it about these ticker timers. You must know, all you need to take care of is the direction at which the object is going. You understand me?
Yes.
By the way, when you look at case 4, ne, I want you to imagine that the ticker timer maybe was placed this way. Ne? Imagine that the trolley was here. And then the ticker timer there with the needle, it was like this. Now it will mean that this thing is moving that side. It means that this thing, we're moving that side. I get?
Yes.
Right. What would you tell me about the velocity?
The velocity.
Mm-hmm.
It's moving from, the velocity is decreasing.
Velocity will be decreasing because as this thing is moving that side, you can see that the distance was large, but now the distance is becoming smaller, right?
Smaller, yes.
So the velocity is decreasing. Perfect stuff. Right. And then now I know that you have the one on your worksheet there at school, right? I don't know, when you look at it right now, are you able to interpret it?
Must try find it.
So what I actually needed was for you to send me maybe a picture of it so that I can display it here.
Oh. I must send you a picture.
Yes.